Hello everyone, I am Siddharthan. Currently, we are in the seventh module of our hands-on machine learning course, and this seventh module is all about building machine learning models from scratch. So the first model that we are working on is a linear regression model, and in my previous videos, I have explained you what is the intuition and math behind a linear regression model and how you can deduce the gradient descent of a linear regression model. And we have also discussed how we can build a linear regression model from scratch using Python. So that was our previous video, and if you haven't watched those videos, I suggest that you watch those videos before watching this one. Okay, so after that only this video will make sense to you. So we have did all these codes in the previous video, where we have built a linear regression from scratch, and we have built this linear regression in a class format, right? So we have did all the things. So we have initiated the parameters, and then we built the define fit function, which is used to fit the data set to our model. And then we use this update weights in order to update weights using gradient descent. And then finally we built this predict function. So we have done all those things, and I hope you are clear up to this particular point. Okay, so now what we will do is, in this video we will try to implement this linear regression that we have built. Okay, so this will be on implementing linear regression from scratch in Python. Okay, so we have a sample data set. So this data set is about the salary of a person. So I'll just show you. So I'll just open this with a notepad. So this particular dataset, so this is a very small dataset, and it contains two columns. One is the number of years of experience of a person and the salary that that particular person makes. So totally we have 30 data points in this particular dataset. Okay, so that means 30 different people and what is the salary that they are making. So we don't have much information about this particular data set. So let's assume that this salary is in the form of Indian national rupees, and it represents the salary per month. Okay, so let's say that a person with 1.1 years of experience makes about 39,343 rupees, and a person with 1.3 years of experience make a salary of about 46,205 rupees, and so on. Okay, so as you might know, this is a linear. There is a linear relationship between years of experience and salary, which means if the years of experience increases, the salary of the person also increases. So in this case, we can use a linear regression model, as there is a linear relationship between them. So this is the data set that we are going to use. So now what we will do is, we will fit this data set to our linear regression model that we have built in Python. And once our linear regression model is learned from this data, we will give new data set and a new data points. So we will give a new values for this years of experience and see what is the value of the salary that our model can predict. Okay, so our model will predict the value of the salary given the experience of the person. So that is what we are going to do in this particular video. And as I've told you, we already have this linear regression class written in code in Python. Now let's see how we can implement this. So I'll just make a text here as using linear regression. So using linear regression model for prediction. Okay, so let's make this text here. So I'll explain you what are the steps that goes on within this particular linear regression model. So I have made this notepad file. So let me explain this to you. Okay, so this is the workflow of a linear regression model. So the first step is we will manually assign the value for learning rate and number of iteration. So in the previous video, I explained you what is meant by this learning rate. So learning rate is the amount of change we want in our parameters like weights and bias. So what is the change in weights and bias you want to give in each iteration of your gradient descent. So if you don't understand what is meant by this learning rate, so I give a particular video in the video description. I have already made videos on this learning rate and number of iterations, so you can refer that one. So first we will set manually what is the learning rate and the number of iterations that we want. Okay, so we can change these values anything we want, and then we will initiate the random weight value and bias value. So in our code we have initiated with the value 0. Okay, so as you can see here, so in this init part we have initiated this is the learning rate and number of iteration. Now this is so these two lines represents initiating the weight value and bias value. Okay, so as you can see here, we have initiated weight value with np.0 self.n. Okay, so we are creating a numpy array with the zeros, and we are initiating with weights. So weight will have an array, and all the values in this weight array will contain the value 0. And bias is an integer value. So there is another main thing you have to note. So weight can be an array, but bias will always be an integer in most of the cases. So we are initiating bias value as 0, and weight we are creating a numpy array. This is because, so the number of weight that you have in a model changes. So it changes according to the data set that you have. So if you see this particular data set, the salary column is the target column and years of experience column is the feature column. So you can call this years of experience as X and the salary as Y. So the number of weights you have in your model is equal to the number of features that you have. So in this case, you have one target column and one feature column. So in this case, we will have only one weight value. Okay. Whereas in some other dataset, we have multiple features. Say, I'll show you the diabetes dataset. We have already worked on this dataset in our YouTube channel. I have made a video on diabetes prediction. So if you see this particular dataset, so I'll just open this in Excel file. Okay, so now as you can see here, this particular dataset contains many columns. It contains many features. So the final column is the output column, and the remaining column are the features. So let's see how many column that we have. So 1, 2, 3, 4, 5. So okay, so totally we have 8 feature columns and one target column. So as I've told you, the number of weight values that you have is equal to the number of features that you have. So in this case, we have totally 8 features. So if you use this particular data set, you will need 8 weights. So there will be a particular weight value for each column. Okay, so that is the one main thing that you need to note. So that's why we are initiating weights as a numpy array instead of a number, whereas bias is just a single integer value, so we are initiating with 0. So that will be the first step in our linear regression model. So first we will set our learning rate and the number of iterations, and then we need to initiate some value for our weight and bias. So you can give random weights, but generally we will initiate with a 0 as the value for weights and bias. So after we did this, we will build the linear regression equation, which is, we know that it is y is equal to wx plus b, where you can consider this w as your slope or weight and b as your bias or intercept. Okay, so it is similar to the equation y is equal to mx plus c, where m is the slope and c is the intercept. So instead of that, we are using this particular notation, which is y is equal to wx plus b. So we have built this particular equation in our define.predict function. Okay, so as you can see, a define.predict return x dot self w plus self dot b. So this is nothing but wx plus b, which is the equation of the line. So that will be our second step. So we will give this random value for this weight and bias, and then we will build this linear regression. Now with this weight and bias value, the model will predict the value of the salary. So if we come back to this data set again, so now we will give the value of this x alone, the years of experience alone, and our model will predict the value of our salary, and that is the role of this predict function. So in this predict function, we will give the value of this x, and this function will find the value of y using this particular formula, which is x dot w plus b. Okay, and now once it has found this y value, now what it will do is, so all the values predicted by our model, we will store it in the array called as y prediction or y pred. So it will be stored here, and so find the y prediction value for given x value for the corresponding weight and bias. So first we had a random weight value and bias value. So now with this random weight and bias value, so if you think about this, so let's say that we know that the weight value is 0 and the bias value is 0 as well. Now if you substitute those values in this y is equal to wx plus b, the equation you will get will be y is equal to, or the salary is equal to, weight is 0, so 0 into x, and plus bias is also 0, b is also 0, right? So this will be your equation. Now with this equation, your model will try to find the value of salary. Why? By using this particular equation. So it will just substitute the values of x. So as you can see here, the first column values in this equation, and it will try to find the value of y. And now all these values will be stored in y prediction. Now what we need to do is, then the model tries to check the loss function. If the loss function is I, that means our model is not working fine. That means our model is inaccurate. So loss function is nothing but the difference between y prediction and true value of y. So true value of y is those values given in this particular data set, and the y prediction value is the values predicted by our model. So it will try to find the loss function, and if the loss function is I, if the value of the loss function is I, it will try to update the parameters. So it will change the value of this weight and bias. So obviously we know that if we give the weight value and bias value as 0, our model is not going to predict well, because for all the values it will predict the value of y as 0. So it is not the correct weight and bias value. So now the model will update the parameters using gradient descent. So that is the role of the gradient descent in linear regression. Okay. Now it will update the values of weights and bias, and that's what we are doing in this define update weights function. Okay, so and the number of iterations we have given already. So if you just go to the step 1, so we are already assigning the value for learning rate and number of iterations. So now the model knows how many iterations it should run. So we have made a for loop here with number of iterations. That means, let's say the number of iterations is 100. That means the model will go through the data again and again for 100 times, and each of these 100 times the weight and bias value will change, and the model will try to reduce the loss function. So that's the idea behind gradient descent. Okay, and this steps will be carried out again and again. This step 3, step 4, and step 5. So the model will try to update the weight and parameters. Again, it will try to find the value of y prediction with the new weight and bias value. Again, it will find check the loss function. So this will be carried on till it reaches a point where the loss function is minimum, and this is called as the training of the machine learning model, where we try to minimize the value of the loss function by updating the parameters such as the weight and bias value. Okay, so finally we get the best model, that is the best weight and bias value, as it has a minimum loss function. And this is the process that is going to happen in the linear regression that we are building. So I hope this is clear to every one of you, and every one of you understand how this linear regression model works. And now we can implement this straight away. So I'll just close this. So you can take a note of this if you want. So this is very important. So I'll come back to my Google Collaboratory. So I have connected my system, and I have also uploaded this salary data set. So I have showed this salary data set, right? So I have uploaded this data set in Google Collaboratory. So now we will be doing processing in this data set. So the first step will be to import the libraries. So I'll just make a comment here as importing the libraries. So we need some libraries for data processing. So for that purpose, we are importing some libraries. And for this linear regression, we have already imported the numpy function. So numpy library as np. So now we need to import pandas, sklearn, and matplotlib. So those are the 3 libraries that we need now. So first I'll import pandas. Sorry. So first is importing the dependencies. Dependencies are nothing but the libraries. Okay, so the first library that I'm going to import is pandas. So import pandas as pd. So pandas is very useful for creating data frames. So data frames are nothing but tables. So it is easier for us to process the data and analyze the data if it is in a more structured form in a table rather than in the form of a notepad file or a text file. So that's why we are importing this pandas. So I'm just importing it in the short form as pd. So most of you might know it, but some of you may be new to this. So that's why I'm explaining all these small things. So every time we don't need to use this pandas, as a lengthy word. So we can just abbreviate it as pd. So this is the general convention that we use, and we import numpy as np, and it is also the general convention. So we have we are importing the pandas library, and now let's import train test split function. So from sklearn dot model selection, we are going to import train test split. So the purpose of this train test split is, so we have this data set, right? So this data set contains 30 data points, and some data points may contain 500 data points, 1000 data points, or 10,000 data points. So it depends on the data set that we have. And whenever we are training our machine learning model, we will train our machine learning model with the training data, and then we will evaluate our model, or we will test our model with the test data. So this is like the evaluation to check the accuracy score of the model. So that's why we need to split our original data set into training data and test data. So that is the purpose for this. And then now let's import the matplotlib library. So at last we will do some visualization procedures also. So that's why we need matplotlib library. So import matplotlib.pyplot as plt. So pandas is used for making pandas data frame. sklearn.model selection. So sklearn is a very important library which has functions like train test split. It also contains a lot of models like linear regression, logistic regression, etc. It is also a very important model. And matplotlib library is used to make plots. Okay, so in this matplotlib library, I'm just importing this pyplot module, and I'm importing it in the short form as plt. Okay, so that's what we are doing in the first step. So we have okay, so there is invalid syntax. So I should give this as from import. Sorry. So from sklearn.model selection, import train test split. Okay, so the next step will be some data processing. So we generally, what we do in machine learning is we will try to see whether there is any missing values in our data set, and some simple procedure like this. So I'll name this as data processing. So this process is called as data pre-processing. So I'll name this as such, data pre-processing. Now what we will do is we will try to load our data, which is in the form of a CSV file. CSV means comma separated values. As you can see, this data set, all the values are separated by comma. So now we will load this CSV file into a pandas data frame. So that will be the procedure. So this step will be importing or loading. So it will be more appropriate to say loading the data from CSV file to a pandas data frame. So that will be the next step. So I'll name this data frame as salary data. So salary data is equal to PD. So we know that PD means pandas. PD.read CSV. So this read CSV is the function which is used to import the CSV file into a pandas data frame. And now you need to mention a quote here. So opening quote and closing quote. And now we need to copy the path of the salary data. So if you want to upload your dataset file in Google Collaboratory, what you need to do is you need to go to this files option, and there you will find this upload option. So upload to session storage, or you can just come to this part and right click. So you will find this upload option. So you can use any of them. So once you give this upload option, you can upload the dataset from your system to the Google Collaboratory session. So I have already uploaded my salary data here. So now I'm going to copy the path. So you can see this three dots, which is the options menu. And from there, you can copy the path of this particular file. Okay. Now we need to paste this in this quotes. So just a second. Okay, so I have pasted this code. So now what happens is this function pd.read CSV will read this CSV data and it will load it to a pandas data frame. So I'll run this. So you can press shift plus enter to run this cell and go to the next one. Okay, so this has successfully loaded our dataset into a pandas data frame. Now let's try to see the first 5 columns in our dataset. So printing the first 5 columns of the data frame. So we have named the data frame as salary data, as you can see here. So salary data dot yet. So this yet function will print the first 5 rows of the data frame that we have. So I'll run this. As you can see here, these are the first 5 rows in our data set. So it contains 2 columns, which are the years of experience and the salary column. And you can also use salary data dot tail. So this function, so you need to mention the parenthesis, so that's very important. So you can also run this in order to get the last 5 columns of the data set. Okay, so it says 29 because numbering in Python starts from 0, so that's why we have 29. So totally we have 30 data points, as the numbering starts from 0 instead of 1. We have 29 here, so that's not an issue. So this salary dot tail data will print the last 5 rows of the data frame. Okay, so I'll run this. So it is used for us to understand what is the magnitude of the data and what the data looks like. So this is the general procedure that we do in every machine learning process that we do. Okay, so that is our next step. Now what we will do is let's check the number of rows and columns that we have in our data set. So in this particular data set, we know, because I told you, right, that it contains 30 rows and 2 columns. But some data set may contains, as I've told you, it may contains 1,000 rows, it may contains 100 columns, and so on. So it is important for us to know how many rows and columns are there in our data set. So that will be our next step, which is to print the number of rows and columns in the data frame. So we can find that by salary data dot shape. So in this case, you shouldn't use a parenthesis like that. So if you use a parenthesis, you will get an error called as tuple object is not callable. So you just need to remove this parenthesis. So it is in the form of your output will be in the form of a tuple, which is an example of a data type. So those doesn't support this parenthesis, so you need to remove that. So yeah, you will get a tuple which contains 30 and 2. The first value represents the number of rows you have, and the second value represents the number of columns you have. So this is similar to the shape of a matrix. Okay, so whereas in the previous cases, as you might know, we have included parentheses, but whenever we are using this dot shape function, we shouldn't use parentheses like this. Okay, so you need to remove that. So we have found that this particular data set, this data frame contains 30 rows and 2 columns. So that is our next step. Now let's check whether there is any missing values in our data set. So that is another main thing. So if you have any missing values, what we will do is we will generally remove those rows and columns that have if it has a lot of missing values, or we can do some processing like imputation. And I have already made a video on this. You can go to the 4th module in my machine learning course, and in that module I have explained to you how you can process those missing values. So it might be useful for you. So this step will be checking for missing values. So we need to mention the data frame name, which is salary data dot isnal dot sum. So isnal parenthesis dot sum. Okay, so I'll run this. So null means missing values, and we are checking whether there is any missing values. That is meant by this is null, and dot sum. So we need to count how many missing values are there. So that's why we are using this sum function. So this is the summation function. So we are counting the number of missing values that we have in each column. So as you can see here, the value is 0 for both the columns that we have. That means there are 0 missing values in years of experience and 0 missing values in salary column. So we don't have any missing values, which is a very good thing. But generally we will have a lot of missing values in the data set that we use for our predictions. So you have to know like what are the processes that we do in order to operate with this missing value. So that's very important. So this particular data set doesn't contain any missing values, which is a good thing. Now what we will do is we will separate this feature and a target. As you might know, in this dataset contains only one feature and one target variable, whereas several dataset contains multiple features. There can be 10 features, 20 features, or even 100 features. So the diabetes dataset that I have shown you contained about 8 features in one target column, right? So the next step will be to split this dataset into feature and target, where the feature is the years of experience, which is the x-axis value or the x value, and salary is the target column, which is the y column. So now let's separate this x and y column, or the feature and target column. So I'll just make a text here as splitting the feature and target. So if you just come to this linear regression equation, y is equal to wx plus b, here y is the dependent variable and x is the independent variable, because the value of y depends on the value of x. So if you consider this particular data set, here the x-axis column is x value is years of experience and y value is a salary, right? So you can say that the salary of a person depends on the years of experience of that person. So similarly, hence we call that this target column is dependent on the feature column. So we call this y as dependent variable, because the value of y depends on the value of x, and value of x is independent. It does not depend on any factors. So we call this as an independent variable, and we write this linear regression equation as y is equal to wx plus b. So you can call this x as feature and y as target. So that's what we are doing here. So we are splitting the feature and target, and now let's store them as x and y. So let's store the feature in the variable x, and let's store the target in the variable y. So now I'll mention the data frame name, which is salary data dot ilog. So we are just choosing particular columns. So that is used by this, that is done by this particular function ilog. So, and here we need to mention the column names. So I'll just mention this as -1. Okay. So I'll tell you what this means just in a moment. So salary data dot ilog square bracket to 1. Okay. Dot values. Now I'm going to take this salary data frame, and I'm going to separate this years of experience values alone and salary values separately. So that's what I am doing here. Here, the first value, like it represents the column number and the row number, and this I have mentioned that there is a colon, a comma, a colon, and -1. This basically means I am just separating this last salary. So I'm just removing this salary. So if you just represent it as let's say, okay, so you can represent it as, let's say, 1 is to 10 is to 1. Okay, so what this basically means is, let's say that we have a data set that contains 10 columns, and in that we just need the first column, third column, fifth column, seventh column, and the ninth column. So you just have a step size of 1. So each the next column will be basically removed. So that is represented by this particular line. So totally we have 1 to 10 columns, and I'm having a step size as 1. So if you run this particular code in a data set that has 10 columns, so your first column will be printed, and the second column will be removed because you have given the step size as 1, and this process will be carried on until you reach the 10th column. Okay, so this is called as the step size. So similarly, we are just removing the last column. So this is another way of doing this. So I'm just minus 1 in the sense I'm just removing this salary column. So that's what we are doing. And the next part will be separating the salary column. So I'm taking this years of experience and storing it in X. So that is done by this first line of code. And in the second line of code, I'm just taking the second column, which is salary data. So I'm just taking this. So the first column is represented by 0 and the second column is represented by 1. As I told you earlier, in Python, numbering starts from 0 and not 1. So the first column has the value as 0 and the second column has the value 1. So I'm mentioning the second column value as 1. So in X, we are taking all the years of experience values, and in Y, we are taking the target column, which is the salary column, and those values. So that's why I'm mentioning dot values. So this will split our data set into features and target, or the years of experience and salary. Now you can just print and see your X and Y separately. If you print X, you will have 30 values, which contains only the years of experience values. And if you try to print Y, you will have the salary value. As you can see here, we have all the salary values. So that is our next step. Now what we will do is, as I've told you earlier, we need to split our entire data set into training data and test data. This is because we will train our machine learning model with the training data, and we will test or evaluate our model with the help of testing data. So that is one main important thing. So this step is common in all the projects that you do, all the use cases that you do. So this is very important step, and this will be splitting the data set into training and test data. Okay, so for this, we have already imported the function called as train test split function from the library sklearn. So from sklearn.model selection, we have imported train test split. So now we need to use this train test split function. So now I have to create 4 arrays. So first is x train, x test, y train, and y test. So what they basically mean is, so we need to separate this x and y, and this data set will be separated into two data sets. So one is training data and the second one is test data. So if you just see this x, we know that it contains all the value of x. So this all the values of x will be separated into two groups. One is the training data and the second one is test data. Now let's say that we have two groups of data, so two groups of x, and the corresponding values of x will be stored in y. So we have some set of values for x train. So all the x values, so sorry, not all the x values. You will have all the training data x value, and the corresponding y value for this training data will be stored in y train. Similarly, you will have few values for your test data. The values remaining from this x train. So the values other than this x train data will be stored in x test, and the corresponding salary value will be stored in y test. So that is what we are doing here. So we are creating 4 arrays where x train contains all the training data for features, and y train contains all the labels or target for this x train, and the x test contain all the test data features, and y test contain all the target values of this particular x test. So these are the 4 arrays, and now we are going to use the train test split function. So train test split, and now we need to mention x and y. So because we know that we have splitted this features and columns, features and targeted as x and y, right? So from this x and y, we need to separate x train, x test, y train, and y test. So we need to mention x and y in this particular train test split function. And we have other parameters as well, which we need to mention. Test size. So let's say that the test size is equal to 0.33. So it is almost 30%. And I'm mentioning random state as 2. So random state is equal to 2. So what this test size means is like, what percentage of data do you want in your test set? So 0.33 means out of this 30 data points that we have, out of the total data set that I have, I want 30% of the data to be the test data, and the remaining 70% of the data will be training data. So in generally speaking, we will take 10 or 20 or 30% of data as test data. So the test data size will be less and the training data size will be more. So in this case, we are just taking 33% or the 30% as our test data, and that is mentioned by this parameter test size, and I'm taking random state is equal to 2. So random state is a very interesting parameter. So the purpose of this is, if you, let's say that you are practicing this particular code, and if you give the random state value as 2 as I'm giving now, your data and my data will be splitted in the same way. But let's say that if I am giving the random state value as 2, and if you are giving the random state value as 1, then your data will be splitted in a different manner. Like your xtrain will contains different values and your xtest will contain different value compared to my values. But if you just give the random state as is equal to 2, then both your data and my data will be split in the same way. Your xtrain and xtest will have the similar values as my xtrain and xtest will have. So that is the use of this random state parameter. So it is just to reproduce the code exactly that we are doing. So that is the purpose of random state, and you can give any number you want. So that is not a problem here. So you can give any number you want for random state. So it is just for reproducing the code. So now we can train our linear regression model. So as you might know, we have built this linear regression model in the previous video. So we have built this in this class. Okay, so this linear regression, now we are going to train this linear regression model using the data set that we have. So we will first train our data with this x train and the corresponding salary value y train, and then we will feed this x test to our trained linear regression model, and it will try to predict the value of y, which is the salary. So now let's see how we can train our linear regression model. So I'll just make a text here as training the linear regression model, and let's create a variable called as model. So model is equal to linear regression. Okay, so this linear regression is nothing but the class that we created. Yeah, so this is this linear regression, and we need to give certain parameters to it. The parameters that we need to give are learning rate and number of iterations. Okay, so we call these values as these parameters as hyperparameters, because like these parameters are outside the model. But there are other parameters called as model parameters. So the model parameters are nothing but the weight and bias. W and B are called as the model parameters, and the learning rate and number of iterations are called as hyperparameters. So we need to give these values manually, learning rate and number of iterations. So let's see what we can do here. So I am loading this instance, one instance of this linear regression, model to this variable called as model. And in this parenthesis, you need to mention the values of the two parameters, which are learning rate and number of iterations. And you cannot assign the values for weight and bias. So the weight and bias will be calculated by the model itself by going through the data. So it will try to learn from the data. It will try to fit to the data, and it will try to determine the weight and bias value. So that will be done by our model, but you need to give the value for learning rate and number of iterations. So that is another main thing that you need to take care of. So now let's give the value for learning rate. So let's give the value for learning rate as 0.02. So you can give 0.01. So you can basically tweak these values and see which values yields you better result. So this is the general magnitude that we use. So I'm not saying that in all the cases we can use this number. So it depends on the data set that we have and the magnitude of the values that are present in the data set. So it basically differs. So it is nothing but what is the amount of change that gradient descent applies to your parameters. So if you see the gradient descent for linear regression video, so you will understand about learning rate. Okay, so that is not a problem, I think. So I'm giving the learning rate value as 0.02, and now let's give the number of iterations as number of iterations is equal to 100 or 1000. So let me give 1000. So 1000 is a good number of iterations. So you can give 100 and check whether your model is working fine. If you don't see that your model is working fine, then you can change the number of iterations to 1000. So you basically can change these values of learning rate and number of iterations and see whether your model is working fine. So I'm just leaving that to you. So you can try different values of this learning rate and number of iterations, and that's one exercise I'm giving you. So now let's run this. So this will load our linear regression model to this instance called as model, and this it contains two parameters, learning rate and number of iterations. So I'll run this. So linear regression is not defined. Okay, so I haven't 1 second. Linear regression, I think I didn't run the code. Okay, so we need to run all these codes, so I just failed to do it. So let's run on the previous cells. So I'll run this linear regression class. Okay, so now we can run this line. So you should do that first itself. So this has successfully loaded our linear regression model. So I didn't run this particular cell, that's why it showed an error. So that's not an issue. Now what we can do is, now we can fit our linear regression model. So if you come to this linear regression class, we have built a function called as fit. So this is the very important function that we have in our linear regression model. So this is the part where our model will learn. So I have already mentioned you all the steps that goes in a linear regression model, right? So the 6 steps that I have made here. So all these process will be carried out in this fit function. Okay, so it is used by the model in order to learn from the data. So it will try to fit to the data, and it will try to find the loss function, and if the loss function is more, it will try to update the weights. So that is what the process that is going on in this fit and update weights. And yeah, now we can fit the data set. So for the fit, we need to give two values. So one is x and one is y, because like if you want to fit a line, you need to give both the x-axis value and the y-axis value. So you need both the x coordinate and y coordinate, and the two values will be our x train value and y train value, so which we have splitted using the train test split function. Okay, so now I'll fit my linear regression model to training data, which is x train and y train. Okay, so now I'll run this. So this process will fit our linear regression model to the data set that we have. Okay, so this process is completed. So this basically takes a very long time. So this data set contains only 30 data points, which is not a huge number. So this training process takes only a few seconds. But if your data set contains say 1000, 10,000 or more data points, in that case your learning process may take a lot of time. And even deep learning models take even more time because they are computationally more strong. There are a lot of things happening there, and you generally have a very large data set whenever you are using deep learning models, or deep learning in the sense neural networks. So in that case, the training may even takes place for several hours or even may weeks. It may occur. Okay, so this is a very small data set, so it doesn't take much time. So it just take few seconds. So this will fit our training data to our model. So fitting is nothing but so just go here. So it will try to randomly initialize the weight and bias value, and it will try to predict the y value, and again it will see whether the loss function value is minimum or not, and this process will be continued again and again until you reach a minimum loss function. So that process is called as fit, or you can call this as the learning process for the model. Now the model has reached the optimum weight and bias value. Now let us see what is the weight value and the bias value that our model has assigned. So the first step which we did is, yeah, so we have assigned the weight value as 0, np dot zeros, and bias value as 0. So that is our first initial value. Now our model will go on changing this weight value and bias value, which is called as the updating weights, which is done by gradient descent. Now let's see what is the final weight value and bias value for this linear regression. So this process is printing the parameters in the sense weights and bias. Okay, so let's do this. So print, so I'll just make a text as weight. So weight value is equal to, so you need to mention model.w 0, and the next thing is print bias. So bias is equal to model.b. Okay, so model is nothing but linear regression. So we have loaded this linear regression to this variable called as model, and we know that w and b represents weight, right? So we have mentioned here. So yeah, in this case, so self dot w is equal to np is 0. So this is nothing but our weight and bias. So if you want to print this values, you need to mention model dot w. So this self is nothing but model. So it basically means this instance that we are giving. So we are giving the value as model, right? So this self will take the value model. So if you want to print the value of the weight that you are giving, weight you are getting, so you need to mention model dot b w and model dot b. Okay, so now let's see what is the value of weight and bias that we are getting. So this is the final value for our weight and bias. So 9514 point so on, and bias value. So this is our weight and bias. So how will be our linear regression equation is, So if we substitute this weight and bias value, let's come here. So y is equal to wx plus b, which is linear regression equation. And now our trained linear regression models equation will be like this. So it will be y is equal to 9514 point so on. I'm just I'm not considering this decimal. So into x plus b. So bias value is 23697. Okay, so 23697. So this is how our linear regression, trained linear regression models equation will look like. Or you can also say that it may look like this. So y is nothing but our salary. Okay, so y is our salary, and x will be our years of experience. So I'll just name this as experience. So our x will be salary. So salary is equal to 9514 plus 2369. So this is how our trained linear regression model will look like. So now when you give a new value of value of the experience, it will try to substitute that value here, and it will try to find the value of salary. So this is how machine learning works. So this may now seem very simple to you, right? So basically, this is how a machine learning model works. So it can be any complex model. So what it actually does is it will try to find this basic equation, and whenever you are giving the value of x, it will try to find the value of y. So that's what happens in machine learning. So it can be a very complex model. So it can be a logistic regression model or support vector machine or any model. So only this equation change. So this is the equation of the line, which is y is equal to wx plus b, and different models will have different equation. But the process that the machine learning does is it will try to get this equation, and then it will put in the values of x, and it will try to find the value of y. So this is the process that takes place in any machine learning model. So it's actually very simple to understand, but the thing is we just need to understand it. So we don't try to understand what's been going on under the hood. So if you try to do that, it will be very interesting for you. So now we can see that this is a very simple step that has been going on, right? So that's one thing that you can appreciate. So this is what happens in your linear regression model that we are building. Now what we can do is, so as I've told you, we have splitted the data set into training data and test data, right? And we have used this X-train and Y-train to train our data, and now we are going to test our model with the test data. So now what we will do is, let's try to find the value of y given the value of x. So for this, we have also created a function called as define predict, right? So this predict function, so whenever you give the value of x, it will find the value of y. So this value will be predicted by this particular equation. Okay, so that's what we are going to do. And one more thing, as you can see here, I have mentioned w and the square bracket 0. This is because, as I've told you earlier, bias will be an integer value, and the weight will be uh, a numpy array. So that's why I'm mentioning a square bracket is equal to 0. So that's one main thing, because we have created weights as a numpy array, right? A numpy array which contains all the values of 0, but bias is a single value. So that's why I'm mentioning this w as square bracket 0, which is addressing a numpy array. So the first element in this numpy array, and the first element is nothing but this particular value. Okay, so that's another thing which you need to take note of. Now let's try to predict the salary value for this x test data. Okay, so this part will be predicting the salary value for test data. Predict the salary value for test data. Now I'll just store all those predicted value in an array called as test data prediction. So test data prediction is equal to model.predict x test. Okay, so what basically happens here is, now we are giving all the values of x test, and our model will try to find the value of y, which is the salary. Okay, so y test is the true value, and our model will predict all those values, and it will store it in the in the array called as test data prediction. So obviously it won't be very accurate or very equal to the y test value. There will be some difference between the test data, the original y value, and the value predicted by our model. So it's obvious, right? So this is because our data set is a very small data set, and it can't do the learning process very efficiently. If you want a very accurate model, in that case your data set should be very huge. So if you have a more data set, or if your data set is large, then your model can make better prediction. So that's one main thing. But now let's try to understand how this process works. So the reason I'm telling you this is, the purpose of this video is to show you how we can build this linear regression from scratch and how we can implement this. So the accuracy score and the loss function value are not important in this particular video. So the idea here is to try to understand how we can implement this and how we can build this from scratch. So don't worry about the accuracy values and other evaluation scores and all. Now let's see how we can predict this value. So we have already defined this predict function in our class linear regression, and as you might know, we have loaded this linear regression into this variable called as model, and that's why I'm, instead of calling linear regression, I'm just using model.predict. So they are basically the same thing here. So model.predict x test. Now given the value of x, our model will try to find the value of y, which is using this particular equation, and it will store all the values in this test data prediction. Now I'll run this. Okay, so now you can try to print all the predicted values. So print test data prediction. Okay, so you can try to print these values, and these are the values predicted by our model. So now what we will do is, let's try to visualize the data set that we have. So I'll just make a text here as visualizing the predicted values and actual values. Okay, so I'm just going to create a matplotlib chart or a graph in which we are trying to plot the x test value with the linear regression model that we have. Okay, so plt, which is the matplotlib library.py plot, plt.scatter. So I'm going to create a scatter plot x test and y test. Okay, so x test and x test, y test, color is equal to red. So I'll explain you what we are doing in this particular part of the code after completing this. So just give me here 2 minutes. So plt.scatter and then plt.plot x test, comma, test data prediction, color. So let's give a different color here. So color is equal to blue. So we are basically comparing the two values. So we know that the true value that is present in the data set is nothing but y test, and the values predicted by our model is this test data prediction. So we are just basically comparing these two. So we are just basically comparing the true values and the values predicted by our model in the form of chart. So because in the case of regression problems, it is easier to do this way, because like there are two types of problems. One is classification and the other one is regression, and I hope you know about this. Classification is one where we try to find it basically means the output is one or the other. So if you consider the diabetes data set that we have, the output will be whether the person has diabetes or not, or the person is healthy. Okay, so you have two classes here. So it is predicting an yes or no kind of a question. So those are called as a classification, and the other type of problem is called as regression, which tries to predict some accurate value. So if you consider this in this data set that we have here, we are trying to predict a numerical value, right, which is salary. So these kind of problems are called as regression. So if you try to predict the classes, it is called as classification, and if you try to predict some values, it is called as regression. So this is an example of a regression problems. And in the case of classification problem, you can use accuracy score as your evaluation metric. Okay, so like if you don't know what is meant by this accuracy score, classification and regression, so you can watch my machine learning project videos. I have did a lot of classification and regression problems as well. So in that I have shown you how you can find this accuracy score and all that. So that is not important for this particular video. I'm just explaining what we basically mean. So for classification problems, you can use accuracy score as your evaluation metric, and for regression problems, you can use mean square error, mean absolute error, and so on. Okay, so and another interesting way to evaluate this model is by visualizing the true value and the predicted value. Okay, so the predicted value is the one which is found by our model, and the true value or the actual value which is present in the true data set. And now instead of using those metrics like a mean absolute error or a mean square error, I'm just going to plot these values. So you can also try to find those values as well. It is simple, and you can see my regression project videos like house price prediction and so on. in order to like if you want to understand how you can find those mean square error and other values as well. Okay, so just a second, I got some connection issues, so I'll just give me a minute. Mm, okay, so I'll just run all the lines here. Okay, so what I'm basically telling is you can try to find those mean absolute error and mean squared error and so on. So now we are going to visualize the true value and actual values. So let this run. So as my runtime is disconnected, I need to run all these codes. So because they won't be saved. Okay, so I'll just remove this as now. Okay, so now we are going to plot this. So I'll explain you how this particular plot works in a minute. So plt.x label work experience, and our y-axis value will be plt.y label salary, and let's name this plot as plt.title, which is salary versus experience, which is the work experience. Okay, so now plt.show. Okay, so now we can plot it. So basically what we are trying to do is first we are creating a scatter plot. Scatter plot is nothing but these dots. So we are plotting the values as dots, and we are plotting x test and y test. So you can see the x test is nothing but our test data features, and y test is nothing but our test data salary values. So now we are plotting those two values in the form of dots, and that is done by this first line of code. So we are doing a scatter plot, and we are plotting the x test value and the y test value, and we are plotting it in red color in the form of a dot. So scatter plot is nothing but all these dots, and now we are plotting a line plot. So for this we are using plt dot plot and the x test comma test data prediction. So and we are plotting this in the form of blue color. So now we are plotting a line, and this line is nothing but the value of the values predicted by our model. So we are to see the difference, we are just plotting the true values, which is y test in dots, and the predicted value in the kind of line. So if the line and the dots are closer to each other, that means your model is working fine, or your model is making somewhat good predictions. If this line is very far away from your these true values, in this case as you might know, this line is nothing but our values predicted by our model. Like say for example, if we give the work experience as 4, you can just come to the point where it reaches this blue color line, and if you see the corresponding salary value, so that will be our value predicted by our model. And for the same work experience, this red is the true value. Okay, so that is the difference between this red color dot and blue, where the blue is the predicted values and red color dots is the true values. Okay, so if the line is closer to all the data points, that means our model is good, that means it is making better prediction. And if this line is not closer to these data points, these red color dots, that means our model is not working fine, it is not making good prediction, and it has a very high loss function. So that is very interesting insight that you can do. So in the case of regression, instead of finding the mean absolute errors or mean square errors, we can use this plot, which is a very interesting metric. So you can visually see what is the distance between the true values and the predicted values. So it is a very good exercise for you. Okay, so you can see here most of the points are closer to the line, but as you can see here, these 3 points may not be closer to it. That is because this is a very small data set, and your training won't be that efficient. So if you need a very good working model, you need a lot of data. Okay, so but this model is actually fine because most of the data are close to it. So it is not possible to build a model where a line fits to all the data points. So that is not possible. So we cannot build a linear regression that fit to all these data points. So that is not possible. So you just need to see whether the line where the predicted value is closer to the true value. So that is one thing that you need to note. And now what you can do is you can just change the learning rate values and iteration values. So now what you do is just change the iteration value as 100. Okay, so I'll just change this value and 100. I'll show you how this works. Okay, so instead of 1,000 iterations, now I'm just giving 100 iterations. That means our model will go through the data again and again for only 100 times, and our weights and bias value will be updated for only 100 times. And now, as you can see here, our weight value and bias value has changed a lot, right? Because in the previous case, we had 1,000 iterations. So I'll just run all the codes again from this particular part. Okay, so now we get different. Okay, this data predictions. So I think it's basically showing the same thing. Okay, so now the plot is somewhat different, right? So if you change this number of iterations to 1,000, let's see whether it is giving. No, no. See this line and see. Let's see whether there is any change in it. I'll run this. As you can see here, there is a change in the line. So your number of iterations and the learning rate actually influences how your learning takes place. So generally, if you have more number of iterations, you will have a better working model. But you shouldn't keep on increasing your number of iterations. Like if you keep on increasing it, there is a problem of overfitting. So you need this optimum values for this number of iterations and learning rate. There are also several procedures to arrive to this particular rate, but let's discuss about this at a later point. So that is called as model optimization. So we will discuss it about later. So what I just wanted to do is just try different values for this learning rate and number of iterations and see how much this changes. So what is the distance between the line and the true values, which is red colored data points and so on. Okay, so that is one thing that you can take care of. So that's it, how you can implement the linear regression from scratch in Python. So that is one more thing that I need to show you. So before that, I'll just give you a quick recap on what we basically done here. So in the previous video, as you might know, we have built a linear regression model and in the form of a class. And then we have imported some basic libraries like pandas, sklearn, and matplotlib. And then we have loaded the salary dataset, which is in the form of a CSV file to a pandas data frame, and we did some processing. So we checked the first five rows in the data frame and the last five rows, and next part we have checked how many rows and columns are there in the data frame, and then we checked whether there are any missing values in the data frame, and then we splitted the data into feature and target. We stored the feature in X and the target in Y, and we printed X and Y separately. And then the important step is that we splitted the data set into training data and test data, and we have loaded this linear regression into the variable called as model, and we have fitted the training data, which is X train and Y train, to this model, and we have checked the weight value and bias value and so on. And then we have finally predicted the value for salary given the value of years of experience using this X test data. And then we have visualized what is the distance between the true value and the predicted value, where blue color line represents the values predicted by our model, and red color dots represent the true values. Okay, so I hope everyone of you is clear about this. And there is another way we can do this. So instead of just having this float, let's say that I don't like this particular part, this is very huge, right? So now what you can do is you can just store this linear regression code separately. Let's say that you want to use this linear regression code for multiple projects, and you don't want to write the same code again and again, right? So in that case, what you can do is you can store this linear regression code in a separate Python file, and then you can call your or you can load this particular code afterwards. Like we have imported this library separately, right? So instead of writing the function for train test split function, we have a ready-made function that has been there in the sklearn library. Similarly, what you can do is you can store all this linear regression code in a separate Python file, and then you can use that code in your multiple projects or multiple use cases in order to use the linear regression. So let's see how we can do that. So it will just take a few minutes. So I'll just copy all the codes in this particular line. Okay, so I'll just copy that, and I'll create a Python file. So for this, I'm using Notepad++. So you can download and install Notepad++. So this is a very useful app for programming. So I suggest that you create this or you install this app in your PCs. So I just open this, and now I'm going to paste all the linear regression code that I have. Okay, and now we also need one more thing here. So in this linear regression, we have used this NP, right? So NP is nothing but our NumPy library, but we have imported this NumPy library separately. So if you just see this, this doesn't contain the NumPy library, right? So we need to include this line as well. So I'll just copy this line also, as we are using NumPy library in this linear regression class. Okay, so you need to include this at the start. So our starts let include this import numpy library as np, and the linear regression, the same thing that we have built in our previous video. Now what you can do is you can, in this notepad++, go to file, and just save the file. So you can save this file as, so now I'm going to save this as a Python file. So you can come to this save as type and you have a different file formats. So you won't see this in a normal notepad app. So you just need this notepad plus plus app for this. And if you just come down, you will see the option for Python file. Okay, so Python file engine, the extension .py, as you can see here. So I want to store this as in the form of py, and I'll just name this file as linreg. Okay, so I'll just give a short form for this linear regression model as maybe linreg model. Okay, so this will store all this code in a Python file, and this is the name of the file. Okay, so this is our Python code now. As you can see here, this has gave some indentation, and now this notepad plus plus basically recognize this is a Python file. Now I'll just close this, and I have another code built in. So it is basically the same thing. So it is basically the same code. The only difference is that this particular cell won't be there. Okay, so this linear regression code won't be there, and I have imported all the libraries in the starting. So your code will start from this particular point. Okay, so you don't need this class now. So instead of just writing this, what I'm doing here is, so I just import my data set, which is salary data, and now I need to import my linear regression Python file, which contained the class linear regression, the model that we built. So this is the file linreg.model. Okay, so now you can import this particular file. So you can so that's what I'm doing here. So linreg, so the name should be the same for this file and here. So similarly, so we know that we can import numpy libraries, pandas, skl, and so on. So similarly, you can store this linear regression in a separate file, and you can call that file here. So linreg model is the name of our Python file, and this code now will import this linear regression model. Okay, so now you can go on running this file. So these steps are basically the one which we have seen before. So these steps are nothing but the same. Okay, so I'm just instead of having the linear regression class, I'm just loading it in a Python file. So all the steps are basically the same, and the only difference is that, so while loading the model, so previously we add this linear regression class, right? So we just use this model is equal to linear regression, and just we gave the parameters. Now what you need to do is, in order to load this linear regression, you need to mention the name of the Python file. So we have imported this linear regression model, right? Lin underscore reg underscore model, which is the name of our Python file, and we know that inside this Python file we have the linear regression model. So you need to call this particular Python file here, which is, you can basically call this as a module. So linear regression model, so this R should be caps. Okay, so linreg model dot linear regression. So this linear regression is nothing but just a second. So if we go there to this Python file, and let's open this with okay, so notepad plus plus, as you can see, a linear regression. So linear underscore regression, and so we have uploaded this file in our collaboratory session, right? So we have uploaded this. So you need to mention this Python file, which is linreg.model, the same as you have entered here, or else what you can do is you can just import this as I've told you, you can just import this in the short form as LR. Okay, so now what we will do is we will just use LR in this case. So you can try that one also. So that is also an efficient method to do that. And so in this case, we can have, yeah, so linreg model dot linear regression, which is a linear regression class, and you can have this number of iteration and learning rate. So you can try the 100 iterations, and then you can try 1000 iterations, or any number of iterations you want. So you can run this same code, and you can see what is the true value and the predicted value and so on. So by this way, you don't need to build this linear regression model every, once in a while you are working in a project. So you can just store this in a separate Python file, and whenever you are working in a use case or a project, you can just import that Python file, and you can do your processing. So this will be a very simple steps. So this is how you can save your model, the code of your model separately, and you can use it for multiple projects. Okay, so that's it from my side, and I hope this particular video is very useful for you. And if you have any doubts, please let me in the comments. I'll try my best to reply to your comments. And and in the upcoming videos, we will try different models like logistic regression, support vector machines, etc. And I hope this particular video is very useful for you, and this is very exciting for you as well. So that's it from my side, and I'll see you in the next upload. Thanks for watching.